Okay, final math exams. The pressure is, yeah, it's real. But what if I told you that the exam isn't this giant mystery it's made out to be? See, the 2026 model paper, it's not just a practice test. It's basically a treasure map. And today, we're going to use it to find exactly where those guaranteed questions are buried. All right, let's get into it.
I'm serious. Just think about that for a second. Instead of trying to study absolutely everything with the same level of panic, what if you could focus your energy on the exact types of questions that show up year after year after year? This isn't about some magic trick. It's about studying smarter. This model paper, it shows us the blueprint. It reveals the patterns the exam is built on. So our first stop is functions. For years, one specific kind of question has been a reoccurring guest on this exam. Honestly, it's one of the most predictable points you can possibly score. If you can master this one pattern, you're already way ahead of the game. And look, don't just take my word for it. Listen to how certain this is, coming straight from our analysis. A question like this will definitely come. That's not a guess, right? That's a prediction based on data. The actual function might change, the numbers will be different, but the fundamental question they're asking you, it stays exactly the same. And here it is. This is our case study. You get a function like this, and you're asked to classify it. Is it one-to-one, which you might know as injective? Is it onto, also known as surjective? Is it both, or is it neither? That is the entire puzzle. The whole point of this question is just to see if you get these two basic properties of functions. Let's just quickly break that down. A function is one-to-one if every input has its own unique output. No two different inputs can give you the same result. And a function is onto if it can hit every single possible output value in its codomain. Your job is just to run the tests for these two conditions. So here's the most important takeaway for this section. Do not waste your time memorizing the answer for this specific function. You need to master the method. Learn how to test for injectivity and surjectivity, and it doesn't matter what function they throw at you. You'll be ready. Okay, let's see what other puzzles we can solve. Next up, we have matrices. Now, I know these can look really intimidating, but again, the exam uses them in really predictable ways. It's better to think of these less as complicated math and more like logic puzzles, where you're just finding a missing piece using a clear set of rules. For instance, a skew-symmetric matrix. Just picture it as a kind of weird control panel. The main buttons running diagonally from top left to bottom right, they're all set to 0. They're off. And every other button has a twin on the opposite side of the diagonal that has the exact opposite value. If one is 5, the other is -5. Knowing that simple rule can let you solve for missing values in a heartbeat. But here's the matrix question that's even more likely to show up. I'd almost say it's guaranteed. You'll be given a matrix, and you'll be given its inverse, but one of the values inside, let's call it lambda, is going to be missing. Your entire mission is to just find that one missing number. It looks tough, but the solution is actually incredibly simple. The key to the whole thing is this one property. Any matrix multiplied by its inverse always equals the identity matrix, that grid of ones and zeros. So you just set up the multiplication, and when you do it, you'll find that all that complexity just melts away, and you're left with one simple, tiny little algebra equation with lambda in it. Solve that, and you're done. And just like that, we've already cracked several of these guaranteed patterns. And, before we move on to the biggest section, calculus, there's one more I have to mention from the early part of the paper, conditional probability. This is always about how the probability of one thing changes given that another thing has already happened. What's the chance of rain given that it's cloudy? That concept is a lock to be on the exam.
Okay, it's time for the main event, calculus. This is usually where students feel the most stress. But here's the secret. It's also where the patterns are the absolute strongest. If you know where to focus your attention, the calculus section is actually one of the most predictable parts of the whole test. Before we dig into the question types, let's just remember what differentiation really is. I love this analogy of a roller coaster speedometer. It doesn't tell you your average speed over the whole ride, right? It tells you your precise, instantaneous speed and how steep the track is at any single exact moment. That idea of instantaneous change is everything. Now, based on the model paper, yeah, you'll see some basic derivative questions. But the topics that are worth the most points, the ones you should really focus on, are finding local maxima and minima, the very top of the hills and the bottom of the valleys on that roller coaster. And, of course, figuring out where the function is strictly increasing or decreasing. Those two applications are your top priority. And now, for the integration side of things. The source analysis could not possibly be any clearer.
Don't think maybe, don't think probably. A question that asks you to find the area of a region bounded by a curve is a guarantee. They said definitely 3 times. I mean, come on. This is a topic you simply have to master. No excuses.
But mastering it also means not losing easy marks because of silly mistakes. For these area problems, you're using definite integration, so remember to use the limits they give you. And always write square units at the end of your answer. And for any other kind of integration, please don't forget the plus C. It's a tiny detail that can make a huge difference.
Hey, want to know another quick win? You will almost certainly get a 1-mark question asking for the order and degree of a differential equation. This is one of the easiest marks on the entire test. The order is just the highest derivative in the equation. It's basically a recognition task. Do not leave that point on the table.
Phew, okay, we've covered a lot of ground here. We've decoded patterns in functions, in matrices, in calculus. So now let's just boil all of this down into one final, actionable strategy, your master key to unlock the most important parts of this exam.
Here they are, the 4 most reliable high-value patterns on your math exam. If you are crunched for time and need to prioritize, this is where you focus. Master the method for one-to-one and onto functions. Practice finding that missing lambda in a matrix. Perfect your technique for finding the area under a curve. And finally, get really comfortable with those conditional probability problems. These 4 patterns are the absolute backbone of this test.
So the code is cracked. The blueprint is right here in your hands. You know which doors to unlock. The only question left is, which one are you going to open first? Because knowing the pattern is half the battle. The other half is practice. So what's your first move going to be?